Here we have the 2016 sequences and series question that came up. So it says, at the first stage of a pattern, a point moves across 4 units from the origin across the x-axis. Then it moves up 2, and then it moves 1, and then each time it moves another point, the distance is half. So it's going to go 4, 2, 1, a half, a quarter. So then it says, how many stages has the point completed when the total distance along the path is 7.9375? So if you want, you can just do out the distances and see when, or we can use a formula. So I'm just going to do out the distances first. So the first, it will have travelled 4, then it will have travelled 2, then it will have travelled 1, then it will have travelled 0. So 4, 2, 1, 0.5, then it will have travelled 0.25, then it will have travelled 0.125, and then I'm halving these each time, and then it will have travelled 0.0625, and I'm halving these each time, and then it will have travelled 0.03125, and then I'll just do one more and see it will have travelled 0.015625. So I'm going to add these up and see if I can get my value of 7.9375. So 4 plus 2 plus 1 plus 0.5, so 7 plus 0.25, and then plus 0.125, and then plus 0.0625, and then 7.7375. So after this value, I get, when I add this and this and this, this and this, I get 7.9375. So that's 1, 2, 3, 4, 5, 6, 7. So after 7 stages, we get that value. But they could have given us a value that could have been after 20 stages, and we mightn't have been able to do it that easily. So we have terms, and we want to get the sum of how much is it. We want to say if we know the sum. So the sum of a geometric series is equal to this, and you get this in your log tables. So that's the sum of a geometric series. But we already know the sum, and we're told that find the pattern that the sum will be 7.9375. So we could let this equal 7.9375 and then figure out our value for n. So let's do that. So a is equal to 4. A is the first term, and then our ratio is a half, because 2 over 4 is a half and 1 over 2 is a half, and we're told that each time we go on the distance was halved. So it's 1 over half to the power of n over 1 minus a half. So I'm just going to tidy this up now. So it's going to be 7.9375 is equal to 4 by 1 minus 4 to the power of 1 over 2n, and then 1 minus a half is just a half. Say if we want to get rid of this half of the here, we could multiply everything top and bottom by 2. So if we just do that, or we're dividing by a half, so we could just multiply on the other side. So 7. So that's going to be 3.96875 is equal to 4. That's going to be 4 minus 4, and that's just going to be 1 will just be the 1, and then over 2 to the power of n. Then if I just go on to another page, sorry about that. And then I'm left with 3.96875 is equal to 4 minus 4 over 2 root n. So now I'm just going to try get my n on one side and the other terms on the other side. That's going to be 4 over 2 root n is equal to 4 minus 3.96875. So I'm just going to 4 minus 3.965. So 4 over root 2 is equal to 1 over root 32. So now I'm just gonna, you see, if I can get rid of my 4, I'll be able to let these two terms equal. So if I'm so here I'm the 4 is above the line, so if I want to bring that to the other side, I can bring that below the line. So that's going to be 1 that's going to be 1 over 2 to the power of n is equal to 1 over 1 to 8. So 2 to the power of something is equal to 1 to 8. So we could we can bring them both above the line because they're both under 1. So 2 over n is equal to 128. So if we want to find our value, so let's see if we can write 28 as 2 to the power of something. 128 is 2 to the power of something. So 2 by 2 is 4 by 2. So 2 by 2 by 2. So let's get to the power of 4 first. 2, so 2 by 2 by 2 by 2 is 16. So let's get to the power of 6. So 2 to the power of, so 2 by 2 by 2 by 2. So to the power of 6 is 64. Let's multiply that by 2 again. So actually 2 to the power of 7 is 128. So we can write that as 2 to the power of 7. So 2n equals 2 to the power of 7. So then n equals 7. So that's a bit of a longer way of getting the value that we are looking for, which is the value in which the sum of all the terms will be equal to our value of 7.9375. So you can do it either way, and you'll get the correct answer each time. And then the next thing we're asked to do is find the maximum distance a point can move along its path if it continues indefinitely. So we're asked to find the infinite, so we know it's a geometric series because it has a common ratio between each of the terms. We're asked to find the sum if it continues infinity. So we want the sum of an infinite geometric series. An infinite geometric series, and that is in our log tables. And if you look up our log tables, we'll get the sum of an infinite geometric series is equal to this. And this only works if the ratio has an absolute value of less than 1. So with our terms, I'll just get the other page that I had all my terms on. Sorry, 1 second. So our terms were 4. The first term was 4, and then 2, and then 1, and then 0.5, and then 0.25. And we want to find the sum of adding those together indefinitely. So the ratio is the first term, the one term over the term before it, and it's each of them have a common ratio of a half, because we are told in the question that the distance is halved each time. So the ratio is equal to a half, so that's less than 1, so that's okay. And then a is the first term, a is equal to 4. So now I'm going to sub this into my equation. So it's going to be 4 over 1 minus a half, and then I'm going to multiply both sides by of the fraction by 2, so that will give me 8 over 2 minus 1, so that will give me a value of 8 over 1, which will just be 8. So the sum to infinity of all the terms going up and up and up is going to give us a value of 8. So now there's another part to this question. It's kind of a lengthy one, and it says that, so I'm going to do out this table. So they give us a table and they say stage, and then the first thing that they want us to look at is a change in x, and then they want us to look at the change in y. So in the first stage, so second, third, fourth, fifth, sixth, seventh, eighth, ninth. So we have to look at different stages. Okay, so when our point, so the diagram they gave us was something like this. So it goes across 4 in the first one. So if that was our x-axis, it would be going across positive 4, and they've given us these values already. So positive 4, 0, minus 1. So in the first one, it goes across 4, but then on the first move, the y doesn't change because it's only going across the x-axis. So y will be 0 in the first one. But then it goes up 2, it told us. So y is going up in the positive direction, so it's going to be plus 2 in the y, and there won't be anything for the x. And then it's going, so it goes from 4, and then it goes 2, and then it goes just 1. But here we see that it's going in the negative direction. So this direction would be negative for x, and this direction would be positive for x. This is positive for y, and this is negative for y. So we see it goes minus 1, but in this time, the x coordinate doesn't change. And then in our next move, our y is going to be going in the negative direction, and it's going to be half 0.1. So it's going to be 0.5, and the x doesn't move. And the next one, the x is going to be going this way, so it's going to be going in the positive direction. That's going to be 0.25, and the y doesn't move. And then in the next one, we can just divide 0.25 by 2. The y is going to be going up in the positive direction, so the x doesn't move, and it'll be 0.125. And then in our next one, our x is going to be going in the negative direction. It's going to be minus 0.0625, and our y doesn't move. And then the next one, our y is going to go in the negative direction, so our x doesn't move. So it's going to be our 0.0625 divided by 2. So I'm just doing that on my calculator, and I'm going to get minus 0.03125. And because y is going down, it's in the negative direction. And then our x is going out positive again. So it's going to be that divided by 2. And it'll be 0.015625. And our y doesn't move in that one. So there are a table of values here. And then it says, find the x coordinates and the y coordinates if continuing indefinitely in this pattern. So we want to find the x coordinates and the y coordinates that the pattern is approaching. So basically, we need to find if the pattern is continuing indefinitely. You want to find the value that x approaches and the value that y approaches. So x, so say if we're dealing with x, this is our pattern for x, this is our pattern for y, and we're told that it continues indefinitely. So say if we deal with x, so it'll be 4 minus 1. So if we just take x, and then it's 0.25 minus 0.0. And then, so if we just look at these values, and we want to get it continues indefinitely, so we're going to have to use the formula of an infinite geometric series. But to do that first, we need to get the ratio between each of these terms, and we need to establish that that has an absolute value of less than 1. So the ratio of the first two terms, 1 over minus a quarter, and the ratio of the next two terms is 0.25 over minus 1, and that will give us a quarter minus a quarter again. And then we'll find that the next two terms will also give us a ratio of minus a quarter. So our ratio is minus a quarter, and that is less than 1. So our ratio just needs to be greater than minus 1 and less than 1. So we can stick that into our formula. So for the x, the first value is 4. And then it's going to be 1 minus a quarter, because our ratio, and then we just fix out that. So the sum to infinity is 4 over 1 plus a quarter. So if we just multiply above and below by 4, we'll get 16 over 4 plus 1, and then we'll get 16 over 5, and they might just want us to put it in decimal as well, and that gives a value of 3.2. So that's our x value. So say if we want to get our y value, our y value, we just look at, so our terms for y, I'll just write them here. So y was 0, and then we got, so I'm not actually counting the zeros. You see, when I just went from the pattern for x, I went from 4 to minus 1 to 0.25. I just didn't count the zeros because it'll just, every second one we're counting. So now I'm going to deal with the y's. So the first one that's not a 0 is 2, and then it's 0.5, and then it's 0.125, and then it's 0.03125. So I'm going to get the ratios between these. Sorry, that's a negative there. So minus 0.5 over 2, that should give us a ratio of a quarter as well. So that's minus a quarter. And then I'll just check another one just to make sure our ratio is minus a quarter. Yes, our ratio is again minus a quarter there, so you can see that. So our first term is 2. Our ratio is minus a quarter, and that's less than 1. So we can use the formula that we use for x. Find our x values. So we stick in a is 2, which is our first term. The ratio is minus a quarter, sorry. So then we multiply, so 2, 1 plus a quarter. So it's going to be 2 over, so we're going to multiply above and below by 4 to get rid of our fraction here. So that's going to be 8 and 4 plus 1. So that's going to be 8 over 5. And then I'm going to plug that into my calculator, and then is equal to 1 over 6. So from the way we found already, we found that x is equal to 3.2 and y is equal to 1 over 6 as each of the values approach infinity. And that is our question done. Thank you.